So to start, what do you mean by this set? Okay, who has somebody is again asking for the permission. Who is asking for the permission? Okay. So we are having 53. Done. So the concept of set. Okay, it's a basic concept, algebraic structure used most commonly in any algebraic operation. The structure is best suited for learning the advanced concepts in data structures like trees, graphs, groups, and so on. The term set theory, was coined by the scientist Cantor, G. Cantor. Okay. So, who has coined this set theory? Okay, this has been coined by G. Cantor. That you should know. Okay. Otherwise, it would be a case that we are learning set theory and we don't know who is the inventor of this set theory. So Cantor has invented the set theory way back in 1845. So there was involvement of the set operations and set theory way back in 1845. So what this set is in every day, okay, while dealing with so many scenarios, so many objects, we are coming across collecting similar type of objects together and making them represent as a group. So if we are grouping, collecting one or more objects together, and if we are interested in naming that particular group, that group will be known as a set. So what is a set? Set is a collection of objects. Okay. But while telling this definition, you must be aware that set is a collection of distinct objects. So distinct word is important while defining the set. Okay. What is the meaning of distinct? I will have all the elements of set as unique. There will not be any repetition of any element in a set. Set is a collection of all non-duplicate elements or objects. That is, you might be recollecting the definition of set from your earlier mathematics. Okay. So we are going to collect and represent that entire collection as a set. I can say set of all students who are joining this lecture are represented by SE computer students. Okay. So if I have to represent them as a collection, I will label them as SECOM, and SECOM represent the entire set of students from second year computer engineering. Okay. Do you have any duplicate of yourself in the same classroom? Obviously not. We are going to have all as unique and distinct. So what a set is? A collection of unique, distinct objects. Object can be anything. It could be a notebook, chalk, pen, pencil, mobile phone, computer, persons, human beings, plants, stars in the galaxy, so on and so forth. So if we are representing them as a group, as a collection, that will form a set. Am I clear? Am I clear? Clear with this definition? Is it fine? Yes. Okay. So have you heard of set theory before in your earlier mathematics anywhere? Have you heard of set theory before? Anywhere? 12th standard. Okay, okay. No problem. So there is no need of stressing more if you have learned this in 12th standard. Okay. So again, you would have something in your mind why we are learning this in the computer science engineering branch. So this theory has been introduced so that you would be better familiar with the concepts of graph, trees, groups and rings. For understanding these concepts in the data structures, like you are having stacks and queues as well in the data structures, you should be aware of the basics of set theory. That is the reason why this part has been introduced. Okay. So what are the applications of set theory? You will find applications of set theory everywhere, wherever you go in a daily practice as well as in real life as well. We are going to use set theory everywhere. I have mentioned examples as well. Okay. So let us see the definition. Okay. While defining a set, you should again be concerned about the unordered word. Okay. Set is an unordered collection of distinct elements. I must say distinct. Okay. This distinct elements. The word is distinct. So unordered collection of distinct elements. Some examples. We are representing a set using a curly bracket. Okay, so whatever comes in between a curly bracket, these are known as elements of a set. So this entire thing, 1 2 3, 1 comma 2 comma 3 is the set containing 1 and 2 and 3. Order is not important. Okay, so this entire, okay, the single thing within a set will be known as an element. We would say it as an element, or it will be known as an object that you have. Okay. As I said, we are not going to consider any repetition of elements. You can observe second example. If I am having a set like this, 1 comma 1 comma 2 comma 3 comma 3, it is equivalent with 1 comma 2 comma 3. Since repetition is not allowed, it is irrelevant in the notion of set theory. 1 comma 2 comma 3 is equal to 3 comma 2 comma 1, as sets are unordered. There is no any ranking of elements or ordering of elements in the set. Okay. The sets can be of three different types, namely finite set, infinite set, and empty set. Okay. Now let me go to my notepad. So I will have types of sets. One is finite, second one is infinite, and third one will be empty. Also, this set will be known as null set. Okay. So when to say finite set? If we are able to count total number of elements in set. Okay. If we are unable to count, then it will be infinite. And what do you mean by empty or null set? Set with zero elements, no elements at all. Okay, if you are defining a set without any elements, you would have it as a empty set. Now, okay, I'm interested to know the various examples of finite, infinite, and empty from your side. Okay, in the chat window, you are going to tell me the answers, examples of finite, infinite, and empty sets. Okay, so that we will have interaction, side by side interaction. Okay. So example, you are going to define any set using a capital notation. So if I define A as a set of numbers from 1 2 3 4, let us say, so this becomes a finite because I can count the total number of elements in set A, which is 4. So finite. Any other example that you would like to give? Other example, let us say, if I'm saying, let's set B be the set of elements of characters of college name P P K B I E. This will be again a finite set, is it? Whatever set in which you can count the total number of elements will be treated as a finite set. Any example of infinite set that you would like to give? Set of integers. Perfectly fine. Okay. Set of integers, because I know that I cannot count how many numbers will be present in the higher side. It goes up to infinity. Infinity is hypothetical simply. So we would say set of integers. Set. Yeah. We are having these notations. Okay, to represent set that we are going to discuss shortly. One, as you said, set of integers, both positive as well as negative. So I must have 0 as well. I will have -1. I will have -2, and I must have something here as well. So dot dot dot, that is infinity, up to infinity. So this is infinite set of integers. Set of stars in the universe, set of vowels is a finite, isn't it? Nika is saying set of vowels. Set of vowels is finite. Because we are having fixed number of vowels in the English alphabet, that is A, E, I, O, U. You may say set of alphabets. All those will come under the finite category. And remaining answers like set of prime numbers, then I am observing 1, 3, 5, 7, 9, that is set of all odd numbers, then set of stars in the universe, set of whole numbers, all are formed in infinite set. Okay, can you give me example of empty set or null set? Set with 0 elements. Any example of this? Set which does not have any element as such. That is notation. Okay, I am asking example. That is the notation that you are showing. This one, or you are using a symbol pi. Okay, pi means you are writing zero and crossing, striking that zero. Okay, even prime number. Abhishek is saying negative natural number. Yeah, yes, yes. Both Abhishek are correct. Okay. You can observe you will not have any even prime number. Okay. You will not have any even prime number except two. Except two. Okay. Except two. I am saying if I am defining a set, let P be set of all prime numbers, all even prime numbers greater than 2. What are the elements of P? Do I have any even number other than 2 which is prime? No. So I will have P as empty. So this is an example of empty or nulls. Abhishek is saying negative natural numbers. Okay. Mridul is saying set of positive integers less than 0. Yes, perfectly fine. Clear. If you are saying set of positive integers less than 0, yes, all those will be negative. So we will have again empty set or pi. So I hope this thing is clear. Okay. So let us go back to our slides. So the null set or empty set is represented using a symbol, this notation pi, or you may use this empty bracket as well. Is the empty set or the set that contains no elements as such. Okay. Moving further. Okay, please note that this phi is not equal to this thing. Can you tell me the justification why this is not equal to? What is slide saying? If we say phi, okay, this one is phi. Phi means empty set. It is not equal to a set containing phi. Why this is so? Can you answer in the chat window? Why this is so? I hope you have got this question. Okay, this is not equal to this because it is element. Yes, yes, in braces. Very nice. Okay. So what that mean? Okay. What this means? If you are writing this becomes like this. The phi will be assumed as a element inside a set. Whenever you are writing anything in a curly braces, you are going to have it as an element, and here it is acting as a set without any element. Here set with one element as a phi. So phi is not equal to in curly bracket phi. Moving further, we are having some notations which are useful for denoting the relationship in between element of a set with the set. Let S is a set of different elements, and if I want to denote X is an element of set S, I am going to use this symbol. X belongs to S. This notation is read as belongs to. X belongs to S means X is an element of set S. If a particular element X is not a member of S, then you would say X does not belong to S. That means X is not an element of set S. Further to this, we are having a special notation to denote a relationship in between one set over the other. If I want to establish a relationship between A and B, I will say A is a subset of B if all the elements of set A are also present in set B. A is a subset of B. I hope this is making a sense. Okay, we are going to see the definition shortly. All the definitions shortly. Okay. So how it is read? A is a subset of B, or B contains A, or every element of A is also in B. How can we represent this in terms of predicate logic? I will say for all X, if X belongs to A, then X belongs to B as well. So we are going to use this. We will study the definition of subset shortly. Okay? For a while, just remember this notation is known as subset. In the context of graphical notation, we are going to use circles for representing the various sets. So B will lie in the outermost circle and A will be contained inside B. The notation of A subset of B. I will come to this point, okay, shortly about this Venn diagram. So observe, if you are writing in this fashion, A subset B means A is a subset of B. And if you are writing it in the other fashion, you would say B is subset of A, or you can say A is a superset of B. Just observe. Okay. A subset of B means B will have at least those many elements present in A. And if you are saying A superset of B, A is going to have more number of elements or at least equal number of elements as that of B. We would say A is equal to B if and only if A and B have exactly the same elements. So I would say two sets are equal if I'm getting that set A is a subset of B. At the same time, if you want both sets to be equal, both should be subsets of each other. So we are saying A is equal to B if A subset of B and B subset of B. Both should hold true. Then only this A will be equivalent to. Okay. This is the thing that I already have shown. If A is subset of B and B is subset of E, okay. The same thing. That means for all x, if x belongs to A, okay, x belongs to A if and only if x belongs to both the sets, that particular element x must be present. Then we are saying both are equal. Now, moving further. Okay, I think you would be confused a little bit. So let us take few examples before we move further. Okay, so if I say A be a set 1, comma 2, comma 3, B is a set having elements 1, comma 2, comma 3, comma 4. C is a set having elements 4, comma 5, comma 6. Can you tell me the relationship in between sets A, B, and C? Chat window. Okay, if we observe the elements of A, those are 1, 2, 3. Elements of B are 1, 2, 3, comma 4. So I will say A is a subset of, but at the same time, B is not subset of. You can observe why A is subset of B. Every element of A is present in every element of B. Okay. But reverse is not true. We are observing in B there is additional element 4 which is not present in A. Hence B is not subset of A. What will be relationship in between C and A? A is not equal to C. A is also not a subset of C as well as C is not a subset of A. And likewise. Okay. How about B and C? Can I say C is subset of B? Again, C is not subset of B. Why? Only one element, that is 4, belongs to B, but we are having these two additional elements 5 and 6 which are not present in B. Hence we will say C is not a subset of B. Let me define one more. Set B equal to 1, comma 2, comma 3. Now this subset notation is okay, very important to understand. You can observe A is a subset of B as well as A is subset of B. Am I clear? Does it make a sense? Am I clear? Whether it is making a sense, what is ongoing, whether the voice is clear and streaming is fine? Yes. Okay. Okay. If it is fine, good, 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 good. This subset will be of two types further. I do not know whether you are aware of or not. Proper and improper. So what do you mean by proper subset? A proper subset is a subset where somebody is asking for. So proper subset, a subset where at least one extra element is present. And the proper subset where values let me broaden it so that you can read out the definitions properly. So proper subset is the subset where at least one extra element is present where in a superset, and improper a subset where values are exactly same without any extra element. So now if you are aware of these definitions, proper subset and improper subset, we can observe the relationship in between A and B will be proper. Okay, why proper? Because I'm observing that B is having at least one more element than that of A. So A is a proper subset of B, while A is improper subset of B. Is it fine? Is it fine? So that is meant here. If we want to denote a proper subset notation, we will write like this: A proper subset of B. Also read it. We are not writing equal to sign here. Okay? A proper subset of B. A subset of B and A is not equal to B, then A is said to be a proper subset of B. So for this example, the example that I have taken, I can write this A proper subset of B, but I cannot write this for D. So for D, I will write A as a subset of, sorry, D, not D. Okay, moving further. So examples for your practice, a quick practice. Okay, so you could observe here, we have been given two sets, 1 comma 2 comma 3, a subset of 1 comma 2 comma 3 comma 4 comma 5. Whether this is proper, whether the first example is proper or improper, that is my question. That is proper. Okay, whether this one or this one, when to write which? Yes, in both the cases. Okay, now the notion of subset is generalized. You are writing like this, but always remember that if there are any additional number of elements present in the right hand side, we will be making use of this notation. This notation is saying that the set can be equal as well, and this notation is saying that number of elements will be more in the right hand side. Okay. Now the next question was whether phi is a subset of 1 comma 2 comma 3. Yes, there is a property that every set is a subset of itself, as well as empty set is a subset of every other set. So using that property, if I have a problem like this, is phi subset of 2 comma 3, my answer will be yes. Using the property, every null set, every empty set is a subset of every other set. Okay, again a question, whether phi belongs to 1 comma 2 comma 3. The answer will be no in this case. Okay. Because I'm saying subset. Okay, being a subset means what? That empty set will act as a subset of any other set, but that empty element will or will not belong to any given set. It depends. Okay, we are observing what are the elements of this set: 1, 2, and 3. Phi element is not present in this set. Hence, if a question is whether phi belongs to 1 comma 2 comma 3, your answer would be no. It doesn't belong to 1 comma 2 comma 3. I hope this is making sense. We are going to have many examples based on this. I'm just trying to refresh the concepts of set theory. Thereafter, we will go for examples. Okay. Moving ahead, again a question to you. whether phi is subset of phi, comma 1, comma 2, comma 3. Question to you. Answers in the chat room. Yes, Viraj is saying yes. Budil is also saying yes. Vikraj is also saying yes. Okay. All are saying yes. Let's check whether it is indeed yes. See here, okay, those who are having confusion, this example and this example. It was specially mentioned that phi is present. Okay, if it is present, perfectly fine. What is the question? Is phi subset of phi comma 1 comma 2 comma 3? While checking out whether phi is subset of phi comma 1 comma 2 comma 3, we are not considering this as an element. Okay, this is element, let it be. But along with this, you are going to have something which is not present, and that is a null set. So, as the property says, null set is a subset of every other set. Using that property, we are saying yes, this is perfectly fine. I am not checking out for this phi. Phi is acting as an element in this set. So if you are having a question over here now, whether phi belongs to phi comma 1 comma 2 comma 3, again your answer would be yes, because now this phi is acting as an element, and in this case phi is acting as a empty set. I hope this is clear. Is it clear? Okay. Let us move ahead. Question for you: is X subset of X? Which time? Okay. What is the answer for this? Whether a set having element X is a subset of set having element X? Yes. Using what property? So we are having property every set is a subset of itself. Using that property, the answer is true. Okay, now for second, what will be your answer? Now the question is slightly changed. Okay, please observe. Is X in curly brace belongs to a set containing X, comma in curly bracket X, curly bracket complete, curly bracket complete. What is your answer? I'm saying yes. Yes means you are getting okay. Yes. Can I answer? You will be yes. Okay. If this particular curly brace is not present in a set, okay. What if? I do have a question. I am now modifying my question. Okay. Let us say my question is in curly bracket X belongs to curly bracket X. What will be your answer in this case? Curly bracket X belongs to curly bracket X. Whether that belongs to is now I am asking the answer for this. In curly bracket X belongs to in curly bracket X. What is the answer? Still you are saying yes? No, it will not be. Okay, why it will not be? Why it will not be? Yes, it will not be correct. Okay, but you should know the reason why it is not. Whenever we are writing like this becomes an element. Okay, and this is a set. On the right hand side, you are having set. So an element with curly braces. So do we have such thing present over here? I am observing that I am having a set with only element as a X. I am not observing this as a bracket. If this is the thing, then you would say that it belongs. Otherwise, it will not belong. Now, how about this? Is X subset of X comma X? Yes. Yes. All are following, girls? Boys are following. Okay, I'm not getting replies from girls. Yeah. Yeah. Fine. 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 That means you are there. Okay. Where were we? Oh. All are saying yes. Let me check yes. Yes. Now X, this thing. Okay. This thing or this thing? While representing a set, I have to check whether this x means this, as we are having single element x as a precedent, so we are saying x is a subset of x. This was my question, no? And I said already this is no. Why no? Try to understand. Whenever we are writing belongs to, on the left hand side there will be element, and on the right hand side there will be a set. So do you observe that in your set you are having an element with curly braces present? No, there exists an element x, but that x is not with curly braces, and we are having element as x with the curly braces. So this will not belong to this. So the answer is no. Any confusions on this? Do you have any confusions on this, whatever I discussed so far? No? No. Okay. Okay. So let us proceed. So the sets can be represented using three forms: explicitly, implicitly, or set builder notation. There are three ways by which I can represent a set. The first way of representing a set is known as explicit, where we are listing down the contents of set directly, separated by the comma explicitly. Okay. The another way of representing a set is implicitly. Implicitly means I am not aware about what is the highest number that will be present in a set. I am defining some series 1, 2, 3, and I am putting out dots to represent a set. This is known as implicit method. And the third method of representing a set is set builder notation. This says that you are going to make use of the form. The form will be like this. This notation is known as set builder notation. So you are saying x. Let me go back to notepad so that things will be more clear. Set builder notation. So it takes a form like this: a, the set of x. We are using this notation. Okay. Vertical line is known as such that x such that p of x. So this notation we are using. P of x is what? Predicate which is true involving x. X is the element belonging to set, and p of x is a predicate involving x. It should be true. For example, if I ask you what are the elements of a such that it is holding a, small a, such that 1, this is the condition involving a which should be satisfied for listing out the contents of it. So I will have here elements of set a as 2, 3, I hope this is clear. Something new. Set builder notation. We are denoting a set using a formula, mathematical equation. I hope the things are clear. No? No. 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 What? No. No for. No for what? Whatever. No for. I think I was asking you. Do you have a doubt? And you said no. So moving further, before I proceed with the slides, okay, let me have some quick recap of number sets. You are already aware of. I am going to introduce you the popular notations used for representing numbers. So if I am using capital N, this capital N hence onwards will denote set of all natural numbers. What are the natural numbers? So that is equal to 1, 2, 3, 4. I would recommend you to have a snapshot of this at the end once I discuss all the sets. Okay. So set of natural numbers denoted using capital N. Moving further, second set. If I have capital Z, this capital Z denote set of all integers. Okay. This is equal to set of all integers as well. Okay. Dot up to -2, -1, comma 0, comma 1, comma 2, everything. Okay. Capital Z makes 3. If I have Z plus will be at the top of Z. Okay, I am writing Z plus, but plus will be at the top. Z plus will denote set of all positive integers. This is very crucial because we are going to use all these sets throughout the concepts of discrete mathematics. Okay, and further as well. So non-zero numbers which are positive will be coming under Z plus. Z minus, again minus is at the top of Z. It is set of all negative integers. This is nothing other than we have dot 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 minus 3, minus 2, minus 1. Be careful, we are not writing 0 in both Z plus or Z minus because 0 is neither positive nor negative. So we will have other elements than 0 present in either Z plus or Z minus. Set number 5. If I write Q, can you tell me what is Q? Q will be all set of rational numbers. Numbers which can be represented in the form of fraction p by q. So which elements do I have in Q? In Q I would have again dot 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 comma minus 4 upon 2. I would have any, okay, I would say minus 1, I would have 0, then I would say 1, then let us say to say 4 by 5, 6, 11, and so on. You would again ask me why 11 or why 0? 0 can be represented as a fraction, 0 upon 0. I can represent any other number, 6 as 6 upon 1, 11 as 11 upon 1, and so on. So everything which can be represented in the form of p upon q is coming under set of rational numbers. It is again having two forms, q plus and q minus. Q plus will be set of all positive rational numbers other than 0. Q minus will be set of all negative rational numbers other than 0. Moving further, R, capital R denote set of all real numbers. I will have all real numbers. What do you mean by real numbers? We would have real numbers, a number which can be represented in the form of decimals, which can be represented in the form of points. Okay. So you will have here all integers, okay, whole numbers. You will have all rational numbers as well here. So you will have minus 22, let us say minus 20.3, minus 2.5, 0, 0.01, 0.002, 1, 1.5, and so on. You will have here everything in real numbers, set of real numbers. Again, this will have two counterparts, r plus and r minus. R plus set of all real positive numbers, r minus set of all negative real numbers other than 0. Okay. Moving further, the 7 number set is known as transcendental numbers. Transcendental numbers. Okay. So what are these transcendental numbers? These are the numbers which are not algebraic. These are known as transcendental numbers. Okay. So what is a? You will have two numbers under transcendental category. Those are pi and e. Pi will hold a value of 3.14. So we are using that symbol pi. Okay. What is the symbol of pi? Let me have it on my slide. If we are writing like this, pi and small e, these two will act as a transcendental numbers. Okay. Further to this, the last set, imaginary numbers. So what are these imaginary numbers? I holding a value of under root of minus 1. So I will come under imaginary numbers. I would recommend you to take a snapshot of this so that we can move further. Okay. So have you taken a snapshot? Any replies in the chat window? And equal to the. So shall I proceed? If you have taken the snapshot, good. This we are going to use consequently while solving any example. No? If you are not, again, one more time. Okay. Further to this, what is the definition of subset? If the element set is also an element of set, then you say A is subset of. Okay, why I am taking the definition? Because it is asked for 2 marks in your theory examination. Define set. Okay, define set. Explain the concept of subset with the help of example. So you are going to give this definition, and we would say it is a subset of B. The properties are properties of subset. First property: every set is a subset of itself. Second property: empty set is subset of every other set. These two properties you have to keep in mind. Okay, for the entire terms. Equality I have already discussed. Moving further, there is one more concept, important and interesting concept known as power set. So what a power set is? It is a set of all possible subsets of a given set. A power set is a set of all possible subsets of a given set. So for example, if you are having set A containing 2 elements A comma 2, its power set denoted using P of A will have how many elements? I will have first an empty set 5 comma 1 comma 2 comma 1 comma. So are you getting what is a power set? It is set of all possible subsets of a given set. So given set is a set containing 2 elements 1 comma 2. So power set will have first subset as 5. Empty set is a subset of itself. Sorry, empty set is a subset of every others. Next, can I have 1 as a subset of this 1 comma 2? Yes. 2 as a subset of 1 comma 2? Yes. 1 comma 2. Every set is a subset of itself. So in general, we are having a formula. Okay. If cardinality of A is n, then cardinality of P of A. Cardinality means total number of elements present in a set. Can you tell me the answer? The question is in front of you. Can you tell me the answer? Yeah. Yeah, 2 raised to n. Perfectly fine. Okay, so there are many questions in your examination based on this. They will ask you, okay, simply, what will be the cardinality of this and according. So you have to remember. So I hope this is clear. Moving further, it is universal set. What is my universal set? If all sets for a particular environment are subsets of given set, then that set. Universal set is some giant set wherein all the other sets under consideration are acting as subsets. For example, if I am saying let SE computer denote the set of all second year computer engineering students, then the universal set will be set of all students of VPKB8. So that is, so obviously SE computer students will be subset of students of VPKB8. So that particular set will act as a universal set. It is denoted using symbol capital U. It's also known as universe of discourse. Is it fine? Shall we go ahead? Okay, you are having other lecture. Okay, no problem. I will take one more example and then we'll stop. Moving further. Okay. So if we are having S as a finite, then the cardinality of S denoted using this is the number of distinct elements in S. Okay. You can observe the example in front of you. 1, 2, 3. I am having cardinality of S as 3. If S is defined as all threes, what will be cardinality? Only one, because we have to count distinct elements in given set. If S is 5, what will be cardinality of empty set? It will be 0. Okay. Can you tell me what will be cardinality of this set? Can you tell me the answer for this? 3. Neha is saying 3. Others, Viraj is saying 0. Okay. 3. I think 3. Okay. Viraj, it will be 3. Yeah, 3. Why 3? Whenever we are writing 5 inside a bracket, this becomes an element. So I am having this as one element, this is other element with bracket, and this entire thing as the third element. So we are going to have this as a 3. This is the point where you are confusing. If we are writing 5 without any braces, that means it is nothing. So the cardinality of 0. We are writing 5 inside a bracket, it becomes an element. So 1 element, 2 element, 3 element. Okay. If we are denoting a set using these dots, it becomes an infinite, wherein cardinality cannot be counted. Okay. If S is a set, then the power set of S is 2 raised to S. We are saying it as P of S. Nothing. P of S. It will be all possible subsets of S. Nothing else. Okay. Also known as PS. I said okay. Say PS is a set of all subsets of S. S equal to A. Then let me clear my ink. Just a second, hold on. Okay, now it will be. So power set of this is 5 comma A. Okay. S equal to A comma B. We are going to have 5 A B A comma B. S equal to 5. This is important. Look, what is the power set of empty set? It will have 2 raised to 0. That means one element present. So that one element is added here. So now the final question for you. What is the power set of this one? You have to tell me the answer in the chat box. What is the power set of this and how many elements do we have in the power set? One. Again, Viraj is saying 1. Okay. You are getting confused. Okay. I am going to have 4 elements in the power set of this. Okay. Viraj, okay. I think you are confused. Okay. How the 4? How many elements now we have here? 1 and 2. How many elements we were having here? 0. 1, 2. So I have to make combinations of this. So just observe. First is this as it is, comma this. Then I am taking only this element, this particular, and this. Okay. This is your original element. Then the element combined as a set, and then the original. So we are going to have 4. I hope this is clear. In case you are having doubt, you can discuss with me. Okay. Today. Next things we are going to discuss tomorrow. I know you are having other lecture as well. So let me first of all, okay, just hold on.